All right, go back in the screen. All right, here we go. So Na2, here we go. So let me see if I can make sure to write this in the thing here. All right, so we have Na2C Oh, three. You guys already have this on your paper. I'm just trying to write this out quickly here. So Cl2 aqueous solution. This is going to be very important for our study here. We have CaCO3. That's going to be our solid. Hopefully you guys can read that. Oh man, we're getting off the screen. Hopefully we'll be able to make it here. So NaCl aqueous solution. Very good. So this is actually, here we go. This is actually kind of called a ionic equation. It's going to actually have all of the compounds in it. However, we got to find the net ionic equation. So we're going to try to find that right now. What you actually have to do for this, first of all, you have to make sure that you're balancing it. So you need to make sure it's balanced. So let's go ahead and look at this. Let's start with our very first element here. So sodium. Sodium has 2 on the other side of the equation right here. It's only 1. So we're actually going to put a 2 right there with our sodium. Let's go to our carbonate right here. So our CO3, CO there, CO3 there. Perfect. Let's go to Ca. Ca 1, 1. Good. Ca, our Cl2, the Cl2, it has 2. Perfect. So we're ready to go. Let's kind of break this down now. Let's put it in individual ions. As we do this, aqueous solutions will always break their ions apart. However, solids will not, and water doesn't either. So let's look at this real quick here. So we have aqueous solutions. So we have Na2 plus, let's break this ion apart here, CO3, aqueous solution, plus our CaCl2, that's an aqueous solution as well. So CaCl2, our aqueous solution right there. All right, and then let's go over here for the solid. Here's the deal. I've already told you, you can't break apart water and you can't break apart solids. This is a solid, so we can't break it apart. So this is going to stay together here. So CaCO3. Make sure you're writing this on your paper down here as well as your worksheet. I'm working it out with you guys today. Here we go. So that's going to be a solid. However, we can break this apart here. We're going to have Na2 and then plus Cl. Here's our ions. We already know a lot about this because sodium is going to be positive. Carbonate right here is going to be our negative. For some reason, I forgot to separate our calcium as well as our chlorine. Not sure why I did that, but let's adjust that here. So Ca plus Cl2. Now we already know calcium, that's going to be positive. Cl is going to be negative. This right here, the calcium, that's all just going to stay together. We're not going to mess with it. Let's go to sodium. That's going to be our positive ion, and calcium our negative ion. Now, before we started class, I kind of wanted to demonstrate to you guys that I was a super big fan of sports. I wanted to be in the game. I was so excited for the Lions. I was so excited for the Vultures as well. I wanted to be for both of those teams. However, have you ever gone to a game and then you have someone who is cheering for both teams? I mean, who does that? I mean, what in the world? What's going to end up happening is that guy's going to be taken out. We don't want that guy there. That spectator, we're not going to want him there. So that's actually what we're going to do here. Oh, man, let's get this in the... There we go. Now we can see it. All right, so this is what's pretty much going to happen. So we see here, we have sodium right here, sodium right here. It's on both sides. It's on both teams. It's cheering for the Lions. It's cheering for the Vultures. Well, guess what? We're going to kick them out. So this is what we're going to do. We're going to knock this out right here. Sodium, we don't want you. You're lame. You're going for both of the teams. That ain't going to happen. Okay, awesome. So let's look at here. So CO3 negative, CaCO3 negative. Here's the deal. We don't have the carbonate over here. It's with calcium. So therefore, one of them's going to cheer for the Lions. One of them's going to cheer for the Vultures. That's just going to how it is going to be. So notice that they aren't going to be kicked out. So the carbonate right here will not be kicked out. Calcium. Let's look at that. Okay, so we have one person over here. This person is cheering. All right, woohoo! Let's look at this over here. So on the other side of the team, or if he goes on the other side, they're still with the CaCO, so they're not actually going to be kicked out of the ball game. Sweet, they get to stay there. Let's look at this. Cl negative, we got that 2 right there. Okay, I think we found someone else here, a spectator ion. So look at this. So Cl2. Let's look on the other side. All right, look right here. Cl2. This is actually 2 right here because we did carry that over here, so we have to take that over. Notice that they're both on both sides of the equation. They're on both teams. You can't have a person at a ball game that's going for both teams. You have to cut them out. So let's cut those out. What we're going to do is put an X right here and an X right here. Now, what are we going to do? Well, let's have the Lion team and let's have the Vulture team versing each other. What's going to happen here? Well, let's see. The screen here. So CO3 negative in our aqueous solution plus Ca. That's going to be 2 positive. If you guys still do have that chart in your book or that I printed out, I gave you guys a while back, you should have that, hopefully. And then here's our equilibrium sign, CaCO3. It's our solid. These are going to be an aqueous solution. Oh, I put Ag, don't put Ag. Aqueous solution right there. And therefore, does this make sense if you look at it? Well, let's see. We have over here on the Lion side, calcium carbonate. Woo, I love the Lions. All right. Calcium, 2 positive. Woo, I love the Lions. All right, let's do this. Let's verse the Vultures. Oh, we hate Vultures, whatever. All right, so CaCO3 solid right here, all right? So if you add all those together, you're going to end up getting that. And that's actually our final answer. This is our net ionic equation. We went through this. We had it right up here. Camera here. We had it right here. We had it all out. And then what we did is we split everything up. We said we don't really care about actually we care about all these people, but we need to split them up in individual ions because we need to see if there's a spectator ion. If there's a spectator ion in our game plan, he's going to be cabooted. Is cabooted a word? I'm not sure if it's a word. Hopefully it is. We'll see. All right, great. That's one example. Well, you know what? Mr. Taylor, let's get some more examples up here. I mean, come on, this is chemistry class. Get us some experience of how we can do chemistry. Well, perfect. I am glad you guys asked. So here we go. Let's get a difficult one here. Let me write this on the board real quick for you guys. Let's have a very difficult one. I actually tried all these already. I'm just trying to find the right one. All right, so we'll start right there. All right, so this one is NaCl. You guys can actually turn over your page if you want. And this is on the back for extra help for you guys. There we go. So AgNO3 nitrates, silver nitrates, going along with sodium nitrate, aqueous solution plus AgCl. And there's our solid. Oh, we got to make sure we look out for that solid because that solid is going to stay there in that game. Head is getting itchy from this band thing. I don't know what. I just thought about taking it out again. All right, so here we go. NaCl, it's an aqueous solution. What can we do? Well, we can break it apart. All right, so let's try it. Actually, that's what we're going to do with everything in here, actually. So let's try it. So we have Na positive plus Cl. Oh, that's not right. It's going to be negative. And then Ag, an aqueous solution, of course, plus NO3. All our ions, this is an ion. Those actually stay together, of course, because you guys understand that. All right, and then we have Na right here. That's going to be our positive. Let's add our NO3. That's going to be our negative. And then AgCl. So that's going to be our solid. Guess what? Solids don't break apart. That's just the thing. They're just going to stay how it is. Notice that water isn't broken apart as well as solids. They do not break apart. Oh, I lost the cap. Okay, that's all right. We'll continue. All right. Here we go. We're on a mission. Let's try to find those spectator ions and knock them out. Let's see here. All right. So we're starting from the left side of the page. Who can help me with that? Let's see. I'm going to try to unmute someone here. Who can help me with this? Someone raise their hand, nod their head, blink. You blink, then I'll call on you. Oh, just because being smart. All right, Zach, we'll go. Oh, Michaela's cover her face. We'll go with Zach. All right, Zach. Let's look up here. What's one of our spectator ions you can find here? Oh, this is not good. I can't even hear you. I think you have to unmute yourself. Let's see. Maybe I have to unmute you. Oh, there we go. What's that? Oh, my headband's in the way? Okay. All right, very good. So, first of all, you already said NA. All right, very good. So you see over here, NA. We have it on the Lions team. Remember the Lions? My high school mascot was Lions. All right, and we look over here. Here is another spectator ion. What are we going to do with those, guys? Someone unmute themselves and tell me. All right, okay, Chloe, come on, give us an answer here. Ah, there you go. You're going to go in and find them and kick them out. All right, so let's kick them out here. So X, 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 X. Very good. All right, I need someone else. Help me. Let's try to go find those people. We don't want them there, right? So how about Anaya? Help us out here. NO3, wow, very good, Anaya. That's exactly right. NO3, notice. NO3 is on this side. He's on the Lions team. And he's going over to the Vultures team. What in the world? You can't do that. So we're going to knock them out. We're going to take them out. We're calling the police, taking them out. All right, very good. So I believe that's the last thing that we have here. Solids, they're not going to break up. We've already told you that. Water, that's not going to break up either. So we're going to keep those. Let's go ahead and rewrite this for you guys. So Cl plus Ag, and then over here our equilibrium sign AgCl with our solid that we had right here. Very good. So that is our equation. We can put our ions in it, and then we can also put, I guess that's about it that we can do for this. If you already know that Cl is a diatomic element, so it has to exist with our tubes. Same thing with our Ag. All right, so let me see here if that's everything you need to cover. Just about. All right, so if you look, I gotta grab my cap real quick. All right, here we go. So we're in right here. All right, so that's pretty much it that we needed to cover for today. If you look in your homework, hopefully you guys downloaded everything. It says write table 15.4 and memorize. You guys need to make sure you know what the strong acids are and what the strong bases are. Very important for you guys to know. Next thing is write the net ionic equation for the following reaction. That is good to know as well. That one's a little bit of a tricky one, so see if you can do your best to solve that problem. That's it. That's all I got for you guys for today. So go ahead. If you guys want to be dismissed, go for it. Make sure you turn in your homework. That was scheduled yesterday. Today. Let's see here. I just remembered. You know what? Today is Wednesday. Try to just do your best to get all this worksheet done and then submit it, and then we'll be all set. It shouldn't take too long to do that because I pretty much hopefully explained it pretty well. So make sure you get this worksheet done and turn in by 3 p.m. tomorrow as well. If you guys are done, we'll see you guys later. Stay online if you have any questions. I'd love to answer your guys' questions. We'll see you guys later.